Hey everybody, I just wanted to spend a little time talking about isomers, and this is where we're going to get into some of the really fun stuff, start getting into some of the fun stuff with organic naming and organic going from names to structures. Now, just so you know, there's a ton of different types of structures or isomers, okay? And so there's some that are structural isomers, then there's things called enantiomers and diastereomers and rotamers and mesomers. There's a bajillion different things called isomers, okay? And so in this particular video, all I'm going to do is I'm going to talk about structural isomers, okay? Structural isomers are isomers that have the same formula, but they have a different Lewis dot structure, okay? And so the way that this can happen is you can end up having groups, like carbon groups, that dangle off the longest carbon chain. Okay, by doing that, that creates structural isomers, and that's kind of pretty crazy. So one of the things that I think is kind of an important skill, or something that is important to do, is to be able to name structural isomers, because if you're trying to come up with all the different structural isomers of some sort of compound, if you can name it correctly, then you know that that's going to be unique. If it's the same name, then it's the same compound, and it's not a structural isomer, it's just the same compound. Okay, so we have to name the longest carbon chain, and then hanging off the longest carbon chain will be groups. And so you're going to and those groups are going to end with a YL. So for example, if it's a one carbon group, okay, like it's a CH3 hanging off of some carbon chain, okay? Now, I'm leaving out a lot of hydrogens, I get it, but this is a one carbon group hanging off of here. This is one carbon, which is meth, all those prefixes. It's not methane, right? Because that implies that it's a standalone compound. We put a YL ending at the end, so that's methyl. Okay? And then we'll talk about the number, and we'll talk about the placement, okay? And so that makes sense as we start talking about structural isomers and getting names down and talking about them. Okay, so one of the things that I think is important is for us to kind of look at this. I'll come back to this in a second, but what I have here is a list of isomers, okay? And so, not a list of isomers, a list of compounds. Okay, and in parentheses here is the number of isomers that exist. So if we look at methane, one carbon, all we can do is arrange this in such a way that there's one carbon in the middle with 4 hydrogens around the outside. There's no other way to arrange this or have a different structure with the same formula. So there's really only one isomer of this, okay? And the same is going to be true with ethane, okay? Ethane is 2 carbons, ethane, 2 carbons single bonded, and then we put the hydrogens in like this, okay? And that's cool. Okay, but there's no other way to arrange that so that they're connected any different than that. Some people will want to maybe put the carbons like this, but all that happened when we did that, I'll write all the hydrogens in. Okay, it's the story of my life, writing hydrogens in all the time. Okay, all we did was take that molecule and just kind of turn it 90 degrees, and that doesn't do anything, okay? Excuse me. So that's the same compound, okay? And they have the same name. Longest carbon chain, ethane, Okay, so now propane. How can we connect the carbons in propane? Well, we can put them out in a straight chain. Okay. Now, is there any other way that we can arrange these guys? Okay, so let me just take a look at the carbons. What if I took the carbons and put them like this? Okay, if I did that, again, longest carbon chain, 1, 2, 3, 3 in a row. That doesn't do that. Okay, what if I go like this? It doesn't matter. That's just taking this guy and kind of spinning him this way, but okay, 1, 2, 3. It's still 3 is the longest carbon chain, just like here, 1, 2, 3, longest carbon chain. So no matter how we do it, there's no structural isomers of propane. There's just one structural isomer of propane. Okay, now let's get into butane, because butane is where the fun begins. Okay, there are actually two structural isomers of butane, or two butane structural isomers. Okay, now when I say that, I mean the formula of them is going to be C4H10, and so we can't tell the difference between those by the formula, so we're going to have to look at the structure. So there's one isomer that I always start with, and that's with the carbons, whichever thing we have, with the carbons all kind of hung out all in one straight line. Okay. By doing that, we have one straight line, 4 carbons. This guy I am going to name butane. Okay, and because it's butane and it's kind of the standard, the normal butane, it actually has a name, N-butane. Okay, because butane could be anything that's C4H10. This is N-butane, the normal butane with the carbons all kind of out in one big long row. Okay, so now I know that there's 2. How do I know that there's 2? Well, I looked it up and I know. Well, plus I have a degree in organic chemistry, so I know that too. But so here, let's look. Let's take our carbons and let's go like this. Okay. Is that a new isomer? Is it the same formula? Yes, it's the same formula. But is it a different isomer? Well, let's count the longest carbon chain. 1, 2, 3, 4. It's the longest carbon chain in a row is still 4. So that's going to be 4 in a row. That's going to be N-butane. Okay? That's still N-butane no matter what. Okay? So here's how I determine what the structural isomers are. Okay? Since there's only ever going to be one N-alkane in the family, okay? There's only one N-butane and propane and not propane, pentane and hexane all down the line. I know that the next one is going to have to be a 3-carbon chain. Okay, and so what I have done is I have taken off one of the carbons, but I still need 4 carbons in the thing. So I'm going to take that and I'm going to put that on one of the ends. Now if I put that on the end, my longest chain still stays at 4. So I want to somehow keep my carbon chain at 3. Okay, let's see. If I put my carbon here, again, carbon chain, longest carbon chain is 4. That's kind of a bummer. Okay. So what we need to do is we need to always, when we take off one carbon to come up with other structural isomers, we need to put the carbon that we removed in at least one carbon. So now if we look and draw carbon chains, no matter which way we go, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, we can't get any more than 3 in a row. So this guy, I'm going to call a propane. Okay. I'm going to call it a propane. And by calling it a propane, let me write this, let me erase it and show you how I'm going to do this. 1, 2, 3. Okay. I'm going to call that my longest carbon chain. Now, I have already named those carbons. Okay. Propane, that means that. So the only thing that's left is to name this carbon with all the hydrogens dangling off of it. Okay. You'll see I'll get lazy about drawing hydrogens in a little bit. Okay. But we have to name that carbon. We have 3 of them, prop. Now how do we name the one? Well, that is a 1 carbon chain. That's a meth 1 carbon chain hanging off the main chain. So that is methyl. So we're going to put that here. Methyl, okay, propane. Now the other thing that we have to do is we have to number which carbon the methyl group is coming off. Okay, and so when we number this, we're going to number this 1, 2, 3. Okay, and when we number that 1, 2, 3, which carbon is the methyl group coming off? Well, the methyl group is coming off the second carbon, right? This is carbon 2 here. Okay, so it's coming off of here, and so this is going to be named 2-methyl propane. Okay, 2-methyl-propane. So, what about structural isomers? So here's some butanes and some pentanes. Okay, and you can see them. And so you can see here are the 2 butanes that we just drew. Notice they have the same formula. Okay, C4H10. Okay, now they're slightly different. Yeah, they're both gases at room temperature, but they have slightly different melting points and slightly different boiling points. And so isomers, structural isomers, are similar but not exact. So that's one of the things in organic chemistry that we have to be careful of. If somebody says, here's a 6-carbon alkane, okay, well, is it the one that has the higher boiling point or the lower boiling point? It's not quite as straightforward as some of the kind of more simple things. So knowing which isomer we're dealing with has importance. And then imagine when you have something as complex as the human body is trying to deal with, separating butane from methyl propane and then some of these other isomers. So it becomes it can become total chaos sometimes. Okay. So anyways, that's our little introduction to isomers, and yeah, it's pretty cool stuff.